In this video, you are going to learn how to find the greatest common factor and how to factor binomials. Please make sure to watch the entire video. And when it says to pause the video and try the your turn practice problems, please do so. Please make sure that your answers agree with the answers that I give on the solutions. And please make sure to write down all of the examples as well as the practice problems. Thank you. So in this lesson, you're going to learn about greatest common factor and then how to use greatest common factor to factor binomials. So we have to first start by explaining what greatest common factor is. And the greatest common factor is the largest common factor between two numbers. Well, that's wonderful, but if we don't know what a factor is, then we don't know what the largest common factor between two numbers is. So a factor are all the numbers that can be divided into another number without a remainder. So if we were to take the example of 12. 12 has many, many factors. 1 and 12, 2 and 6, 3 and 4. Okay, so 6 is a factor of 12. 2 is a factor of 12. But 9 is not a factor of 12 because if you try to divide 9 into 12, you get a remainder. 9 doesn't go into 12 evenly. You cannot divide 12 by 9 and get a number without a remainder. So factors are numbers that go into another number. So if I were to ask you to find the greatest common factor of 12 and 18, there's a couple of different ways to do it. You could sit there for a while and you could be like, okay, the factors of 12 are 1 and 12 and 2 and 6 and 3 and 4. And you could do the list method and you could do the same thing for 18, 1 and 18, 2 and 9, 3 and 6. And you could compare your two lists and you can be like, bam, 6 is the greatest common factor. Now there are two issues with this method. Number one, if you miss a factor, like if I were to miss 6 in one of my lists, then I would have thought that 3 was my greatest common factor. So that's one issue. The second issue is when you get to very large numbers like 240, your lists are going to be very, very long and it's going to be a little bit more difficult for you to figure out how to figure out every single factor. So we're going to go with my favorite method, which is the ladder method. And the reason the ladder method is my favorite is because there are a number of different ways to do it. So every single person can pick a starting off point that's a bit different, and you end up getting the same greatest common factor. So the first step is to place the numbers next to each other and create what I call like a ladder rung. When you look at the two numbers, you're going to ask yourself, give me one factor. It doesn't have to be the greatest common factor. It just has to be a factor. So in this case, I'm looking at two even numbers. So I can say to myself, well, common factor is 2. Some of you may have been like, yo, I know that 3 is a common factor. I know that 6 is a common factor. So great, wonderful, beautiful. I'm picking 2. And I say, okay, 2 goes into 12 6 times. So I divide 12 by 2 and I write down the number below the 12, and 2 goes into 18 9 times. And then I look at the two numbers on the bottom of my ladder now and I say, hey, are there any common factors between 6 and 9? And I say, sure there are. Common factor of 3. When I divide 6 by 3, I get 2. When I divide 9 by 3, I get 3. And then I ask myself the question again, are there any common factors between 2 and 3? My answer should be no, because 2 and 3, the only common factor is 1. So my ladder is complete. Here's the important part. When you're figuring out what your greatest common factor are, you know that 2 is a factor of 12 and 18 and 3 is a factor of 12 and 18, but in order to find your greatest common factor, you're going to have to multiply only the numbers on the left side. Okay, so you're only going to do the numbers that are sitting on the vertical side of your ladder. So when I do 2 times 3, I get the same 6 that I got when I did my listing method, but this time I know for sure that it's my greatest common factor because I have gone through every single factor and just multiplied them. So here are 2 examples. You may pause the video, try them yourself. You may walk through the first one, try the second one by yourself. However you want to work it, please watch both of them. So I'm going to show 2 different ways of doing 24 and 60, the greatest common factor. Because everybody's ladders could look a bit different and we could all end up with the same greatest common factor. For the left one, I'm going to say, you know what? I'm really bad at factoring, but I do know that 2 goes into all even numbers. So 24 and 60 is even. I'm going to divide 24 by 2. I'm going to divide 60 by 2. And I'm going to get 2 more even numbers. So I'm going to be like, okay, I'm going to take out another 2 because 12 is even and 30 is even. And I get 6 and 15. And I get to a place where I can't take out a 2 because 15 is not an even number. But 6 and 15 have a common factor of 3. So I'm going to divide both by 3, and I'm going to get 2 and 5, which don't have any common factors besides 1, so my ladder is complete. I look at the side and I say, okay, so I'm going to have to multiply, because factor means multiply, my 3 numbers on the side, and 2 times 2 is 4 times 3 is 12, so I get a greatest common factor of 12. And I can make sure that this is actually a common factor because 12 goes into 24 twice, and 12 goes into 65 times, so I know that it's a factor, and it seems to be the largest one based on my ladder. I'm going to do the right side a bit differently. Instead of starting out by 2, I'm going to start out with another common factor that I know, which is 6. And 24 divided by 6 is 4, and 60 divided by 6 is 10. So I get to a place where 4 and 10, they're both even. I'm going to factor out 2 because even numbers can always be divided by 2. When I divide both by 2, I end up with 2 and 5, just like I did on the left side. So I already know that I can't take any other common factors out of 2 and 5. So now I'm going to stop my ladder, and instead of multiplying 2 times 2 times 3, like I did on the left, I'm going to just multiply 6 times 2, which is going to give me the same old 12. So no matter how you start your ladder, you're going to end up at the same place, and you're going to end up with the same greatest common factor. Second one, 25 and 90. I'm just going to do this one way. Because both numbers end in 5 and 0, I know that a common factor is 5. And 25 divided by 5 is 5. And 90 divided by 5, if you don't know what that answer is, okay, you could just do a division on the side. And when you do that division on the side, you should get 18. And if you said to yourself, well, I don't know how to divide that, and you struggle a little bit with division, you could figure out that 5 times 20 is 100, which means that 100 is 10 more than 90, so that would be 2 5 factors less than 20, which would be 18. And if you have no idea what I just said, just know that you're getting to 5 and 18, and you're saying to yourself, does it have any common factors? Well, the beauty of this is 5 is a prime number. And because 5 is a prime number, it means it doesn't have any other factors besides 5 and 1, and 5 doesn't go into 18, so I know that I'm done. That's what I call a mini ladder, because the greatest common factor is the first number that you happen to divide both by. So we're going to write 4x plus 16 in what we call a factored completely form, where we factor out the greatest common factor. So in order to factor out the greatest common factor, we have to figure out what the greatest common factor is. So in order to figure out the greatest common factor is, you're going to do exactly what we did in the last couple of slides, except now the little twist is that there's an x. Well, the good news for you is, if both terms don't have an x, we don't have to worry about the x. And in this lesson, both terms are not going to have an x. So we're just going to rewrite the x because x can't be part of our greatest common factor if both terms don't have an x. And we're just going to look at the numbers and we're going to say, what is the greatest common factor between 4 and 16? You can start it by a 2. And then you get 2x plus 8, because 4 divided by 2 is 2, and 16 divided by 2 is 8. And then you would have to say, well, 2 and 8, that is a common factor of 2, in which case you would have x and 4. When you got to this point, you would say x and 4, or 1x and 4, have no greatest common factors. So you would take the numbers on the side just like you did before and multiply them. But now you're going to have to take what's left and put it inside a set of parentheses, because we are writing a factored completely binomial, two terms, as the greatest common factor times whatever's left on the bottom. And again, everybody could factor 4x plus 16 differently, but the bottom line is you're going to multiply whatever's on the left, and that's going to be your greatest common factor. And what goes inside the parentheses is whatever's left. The good news about this is we've spent a ton of time distributing, and we can check to make sure our answer is correct by distributing. So when we distribute 4 times 1x, we get 4x. When we distribute 4 times 4, we get positive 16. And that matches. And because that matches, we know that our final answer that we have, 4 times 1x plus 4, is our correct answer. So if we do 8x plus 4 and we factor out a common factor of 4, we get 2x plus 1. and we write it as the product of the GCF times whatever's left. So the GCF goes outside the set of parentheses as the multiply that you're going to multiply, and 2x plus 1, which is what's left, goes on the inside. And you can make sure that this is correct by distributing. So here are 3 examples for you. I want you to pause the video, I want you to write them down, I want you to try them, and then I want you to unpause the video to check your work. So pause the video now. So if the video's unpaused, then you're watching me do the solutions. If you just want to check your answers and then watch the solutions, fast forward to the answers, go back to watch the solutions. So in this case, I know a greatest common factor. I'm just going to go, hey, I know 6. In this case, I get 5 and 8. 5 and 8 don't have any other common factors, so I know that my GCF is 6. If you did 2 for your first common factor, then you got 15 and 24, at which point you should have then done 3 and got the same 5 and 8, but then you would have had to multiply 3 times 2 to get 6. To factor 6x plus 20, greatest common factor is, well, I'm going to pull out a 2 because they're both even. I get 3x plus 10, and I say to myself, hey, you know what, that 3x plus 10, there's no other common factors of 3x and 10, so I'm just going to write my answer as the greatest common factor times what's left. And I could check my work by doing 2 times 3x and getting 6x, and 2 times positive 10 and getting positive 20. The last one, I'm going to factor out a common factor of 5. I get 2x, and I remember that 5 divided by 5 is minus 1, and I must put that there. And then I write the answer as the greatest common factor times whatever's left. And those are my 3 answers. If you got those 3 answers right, then you understand everything in the lesson. And if you're confused on something, you have written on your video worksheet, I need help with blah.